be in this ratio. Okay, I will give you a very simple example here. Let's say you and your sibling are there, okay? And if you are getting one chocolate, your sibling should get two chocolates. That's the ratio, 1:2. You are getting one, then your sibling should get two, okay? Twice of whatever you are getting, correct? So now if I give you 6 chocolates, how many chocolates should your sibling have? 12, right? Just double of that, correct? So basically, now if you are having 6 and your sibling is having 12, what is the ratio? 1:2, right? You are having one time of what he is having. Yes or no?
Yes, ma'am.
That's the same thing here. Whatever ratio we are having, that should be the ultimate thing. Whatever mass we take, it should actually simplify to this ratio, that is 5:2. So this is for calcium, this is for oxygen. Now, how much mass do we have for calcium? 30 grams, correct? Now, let's suppose this is the mass of oxygen needed that will result in this ratio when calcium is 30 grams. Let's suppose that as x grams, okay? Now, this is simple math. We can just cross multiply them. Yes. So 5x is equal to 30 into 2. Yes. So therefore, 5x is equal to 60 grams. X is equal to 12 grams. Did you solve it the same way?
No, ma'am.
Anyhow, this is the method to solve it. Even if you are using the method that we have 30 grams and this, that's fine. But the point is, when we are using this law, which is constant proportion, you use this ratio. Okay, that's the simple point here. Use the ratio.
Okay,
understood? Any problem?
No, ma'am.
No. Now, I want to have some questions here. Just give me 1 second. I'm opening the question. Yes. Omar, please pay attention this side. Come to the first question. 5.3 grams sodium carbonate reacted with how many grams of acetic acid? 6 grams. So these become the reactants. Sodium carbonate and acetic acid become the reactants. Okay. What are the products that we are having? 2.2 grams of carbon dioxide, 0.9 gram of water, and 8.2 grams of sodium acetate. Law of conservation of mass. What is law of conservation of mass? Mass can neither be created nor destroyed. Basically, the total mass on the reactant side should be equal to the total mass on the product side. That's it. What is it that we need to do? If it is asked to check for whether it is following the law of conservation of mass or not, what we will do, Umar? Hello. Hello. Yes. Umar, am I audible now?
Yes, ma'am.
Okay, fine.
Ma'am.
Yeah. What I was telling you is that whenever we are asked to show whether the reaction, whatever the question is, it is in accordance with the law of conservation of mass or not. Okay. So you just have to do one thing. check whether the total mass of the reactants is equal to the total mass of the product or not. Is it clear? That's the only thing that you will check. So here, if you see the total mass of the reactants, what is it?
Ma'am, we have to find it using cross multiplication, right?
No, bache. Total mass on the reactant side, 5.3 and 6. How much will it give you?
5.6. Ma'am, it should be
You see here.
11.6.
The question is given like this. See, if you write what is the question saying, the question is saying this. We have acetic acid. Okay, how much is it given? 6 grams. Plus we have sodium carbonate. How much do we have? 5.3 grams, correct? And the question is saying the products are, so definitely we will be writing them on the product side. Okay, carbon dioxide, water plus sodium acetate. And what is the amount here? Please pay attention.
Yes,
2.2
ma'am.
grams of carbon dioxide, 0.9. 8.2 grams. See, this is what the question is saying, okay? And the question is asking to show that this reaction is in accordance with the law of conservation of mass. Law of conservation of mass, okay? Now to show that
Okay,
what does
ma'am.
the law of conservation of mass say? See, look here. Total mass on reactant side should be equal to the total mass on the product side. If we are able to prove this, okay, if this has been proved, that means it is in accordance with the law of conservation of mass. Is the concept understood or not?
Yes, I'm understood.
And these are the reactants, these are the products. Clear? So let's add on the reactant side. What is the total that you get on the reactant side? We are just concerned with the mass. So 6 grams plus 5.3 grams. Yes or no?
Yes, ma'am.
What do we get? 11.3 grams, correct? Fine. Now let's see it for the product side. Should I write it like this, Umar? 0.9 grams plus 8.2 grams, correct? Is it the correct way of writing? Yes, this is how we will write. What is the total that we are getting here? Calculate it, see. 2.2 plus 0.9, 3.1 plus 8.2, we get 11.3. Yes or no?
Yes, ma'am.
You have not revised it and then you are not interested in the class. That is now how it is going to work. What do you see here? The total mass on the reactant side and the total mass on the product side, are they not equal?
Yes, ma'am, they're equal.
So what does it mean that it is in accordance with the law of conservation of mass?
Yes, ma'am.
Therefore, yes, it is in accordance with the law of conservation of mass. That is how you are going to solve it. Next question. Look here, see. Come to the second question very quickly. You will solve it yourself very quickly. I've told you how to solve this. What is
Done,
this
ma'am.
law? Okay, what is the answer that you got?
Ma'am, I got 24.
Okay. Now tell me, how did you solve it? What should I do
Ma'am,
here?
ma'am, 8 by 1 multiplied by 3 is 24.
Okay, so hydrogen and oxygen. What is the ratio for hydrogen to oxygen? 1 or 8?
Hmm,
Should I write 1 in the numerator?
hydrogen is hydrogen is 1 and
Hmm.
and the mass is 8.
Bachche, this 8 is the ratio for oxygen, okay? This is not the
Yes,
mass.
ma'am.
Ratio for oxygen, huh? Now see good. What is the mass given for hydrogen? 3.
3.
We need to find x. We need to find the mass of oxygen. We crisscross them. We get x is equal to 24 grams. Good. What law is this?
Not sure, ma'am.
Why not sure? Umar, check it. See it. We have just now solved it. The last question.
Ma'am, law of conservation of mass.
Are we really conserving the mass here? No. We are using
Hmm.
some proportion of elements to form the compound. What is it? Law of constant proportion. What are we saying? The proportion is fixed. For water, when two elements are joining to form water, the proportion is fixed. Please say yes or no.
Yes, ma'am.
And therefore, we are using constant proportion. What does constant means? Fixed, right? Or
Yes,
also called
ma'am.
as definite proportion. You better revise it in the next class. Otherwise, I will directly start the next topic without anything.
Ma'am, I think we should start the next topic.
No, you are not able to solve any question and we should start the next topic.
Yes,
Then,
ma'am, because our school is moving very fast.
so then who is at fault for this? Let's suppose I start the next topic and the theory will not come, the questions will come. Will you be able to solve it?
Ma'am, kinda.
Okay, then fine. Solve the third question.
Okay, ma'am.
Done. Done.
No, ma'am, still doing.
Yes.
Almost, ma'am. I think that, ma'am.
What is the answer?
Ma'am, the answer should be minus 11 grams.
Minus 11 grams?
Yes, ma'am.
And you are saying, bache, listen. Hydrogen and oxygen combine together to form the water. Correct? That is one thing. What is the ratio in which they combine? 1:8. 1:8. So let's first write the ratio. 1:8. Okay. Hydrogen and oxygen. What mass of hydrogen is given? What mass of hydrogen is given? 3 grams. 3 grams of, sorry, we are using it for carbon dioxide. Just 1 second. What is the ratio for carbon dioxide? Carbon and oxygen, what is the ratio?
3 and 8.
3:8. Or carbon is to oxygen to form carbon dioxide. Carbon 3, oxygen 8. What is the mass for carbon given?
Carbon is 3. 3 gram.
Just 1 second. I'll share. So 3 grams of carbon is given. 3 grams. How much amount of oxygen is given? 50
8
grams.
gram.
And the question is asking what mass of carbon dioxide will be formed when 3 grams of carbon is burned in 50 grams of oxygen. If we have 50 grams of oxygen and if we have 3 grams of carbon, what is the total mass of carbon dioxide going to be?
Ma'am, minus 11.
No, you see here. So when we have 3 grams of carbon, it will react with some amount of oxygen. And what is that amount of oxygen? We get that amount as 8 grams only. Even we have 50 grams, but only 8 grams of that 50 grams will be reacting with carbon because carbon is how much?
Carbon is 3.
3 grams. So even if we have 50 grams, 100 grams of oxygen, it will just react with 8 grams of oxygen. Why? Because the ratio of them to react to form carbon dioxide is 3:8. Are you getting this?
Yes, ma'am.
And so total, if we have 3 grams of carbon plus 8 grams of oxygen, how much of carbon dioxide do we get? 11 grams of carbon dioxide. Understood or not?
Yes, ma'am.
And what is the law which is governing this?
Law of conservation of mass.
Are we really conserving mass here? We are following the proportions which is fixed for every compound. Okay. So even some large amount of mass is given, only the mass which is reacting in a proportion will be used. Solve 7th and 8th very quickly. 7th first in 1 minute.
Done,
What is the
ma'am.
mass that what is the answer that you are getting?
Ma'am, I'm getting 15.
15. Good. So 3 upon 8 is equal to x upon 40. You will multiply and you will get the answer. Come to 8th question, and it is a very, very, very important question. Solve this. It's a very important question.
Ma'am, I forgot decimal division.
Use a calculator, bache, but the concept here is more important. What is the concept that you are using here?
Ma'am, for the first part, I'm just going to divide copper and oxygen masses
How
that we
much
are
is the
taking.
oxygen mass in the first part?
1.08.
And how did you get that?
How did you get? Because ma'am, it says 5.40 minus 4.32.
What is 5.40?
5.40. It's the mass of nitric acid, I think.
No, it's the mass of copper oxide. And what
Okay,
is
ma'am.
4.32?
And 4.32 is equal to it's the vapor of copper oxide which is formed.
It's the mass of metallic copper. Okay? It's the
Yes,
mass
ma'am.
of metallic copper. See, this is the equation. In the first part, we have two methods here, right? In both the methods, we are preparing what? Copper oxide. Fine. So see, we are preparing it by two methods. First is we are having copper plus we are taking some amount of oxygen through nitric acid and then we are getting copper oxide. Okay. And we have the mass here as 5.40 grams, right? And we have the mass here as 4.32 grams. Now, this is the equation that we have. Now, what we will do, first we will apply the law of conservation of mass. What does the law of conservation of mass say? The total mass on the product side and the total mass on the reactant side should be equal. So we will do it like this, see, plus x grams will give us what? 5.40 grams. X is equal to 1.08 grams. This is the answer that you get.
Yes, ma'am.
Fine. Now next point part. In the next part, what is the question? How much of copper oxide is there?
Ma'am, 4.32. No, ma'am,
Bachchan,
2.30.
2.30. And what amount of copper we have?
1.84.
And how can we write this? See, so we have copper oxide. This is the second method, which is decomposing to give you copper plus oxygen. We have how much mass for copper oxide? 2.30 grams, 2.30 grams, and 1.84 grams. How can we get the mass of oxygen here? Again, the total mass on the reactant side will be equal to the total mass on the product side. So 2.30 minus 1.84 grams. How much do we get? Okay. Now in both
Okay, ma'am.
the situations, just what now we have the masses. What do we need to do now? That is the most important step.
Divide
Divide by what?
copper.
See, now what do we need to do? Basically, we want to show that in both the scenarios, in both the parts, we are having copper and oxygen combining in the same ratio because the compound formed is same, right? We will try to show that the ratio is same. And how we will show that? The first part, what is the mass of copper? 4.32 grams, right? What is the mass of oxygen? 1.08 grams. In the second case, what is the mass of copper? 1.84 grams. What is the mass of oxygen? 0.46 grams. Just divide them. 1 za, 4 za. If you multiply 0.46 into 4, what do we get?
Ma'am, I don't know.
1.84. Umar, you need to use your hands and mind, bache. We get 4:1. In both the cases, what is the proportion? What is the ratio that we are getting? 4:1. 4:1. What does this show? That law of constant proportion is valid here. It is followed here. That's it. Very important. These type of questions are very important. That's it. Any problem in this topic? Then we are moving on to the Dalton's atomic theory.
Yes, ma'am. Next, let's move on.
Omar is so done with these questions. Delta S atomic theory has some postulates. Okay, we'll try to understand these postulates, but before this, it was given by John Dalton in 1808. 1808. Now let's quickly go through the postulates. See, according to Dalton's atomic theory, all matter, whether an element or a compound or a mixture, is composed of small particles called atoms. The same thing which was said by the Indian and the Greek philosophers. Everything is ultimately made up of atom because that is the smallest particle. Now, the postulates regarding this theory are this. All matter is made up of very tiny particles called atom. Any problem in this point?
No, ma'am.
No. Which participate in chemical reaction. Now, see this point. It is the atoms which are participating in the chemical reaction. Let's suppose you have water in a chemical reaction. Okay, you add water in a chemical reaction. What is it that is actually participating in the reaction? The atoms of water and atoms of hydrogen and oxygen, they are participating in the reaction according to the postulate of Dalton's atomic theory. Come to the next point. Atoms are indivisible, which cannot be created or destroyed in a chemical reaction. Now, according to him, the atoms are indivisible. Now, this was a failure because what we know now is that atoms are divisible, right? Write it. The drawbacks of Dalton's atomic theory, write it. Drawbacks of Dalton's atomic theory. Yes. So write it in the second point. Write it for the second point. The Dalton's atomic theory said that atoms are indivisible particles. Are you writing it?
Yes, ma'am, writing.
Okay. The Dalton's atomic theory said that atoms are indivisible particles.
Done, ma'am.
But this was a failure. I mean, this was wrong, right? This is wrong.
Done, ma'am.
As as
As
later as later it was found out later it was found out
done, ma'am.
that atoms are
Done, ma'am.
further divisible into
Done, ma'am.
subatomic particles
What, ma'am? What, ma'am?
subatomic particles divisible into subatomic particles,
Done, ma'am.
that is electron,
Done, ma'am.
proton and neutron. Electron, proton and neutron.
Done, ma'am.
Okay, write it in the next line. This was the drawback of Dalton's atomic theory.
Done, ma'am.
That's it. Come to the next point. See, now according to him, atoms are indivisible, fine, and they are participating in the reaction, that is fine. Which participate in the chemical reaction? Now, according to him, atoms cannot be created or destroyed in a chemical reaction. What does this show? That let's suppose we are having the reaction as it is, okay? The combination will change. The atoms will remain as it is. And what does that show? The mass of the atoms is intact. Therefore, the law of conservation of mass is actually shown by this postulate of Dalton's atomic theory. Write it. This point, do you understand this point? Which cannot be created or destroyed in a chemical reaction. This point shows that it is following the law of conservation of mass. Okay?
Okay, ma'am.
If there's any problem and confusion, please ask. Do not stop yourself.
Done, ma'am.
So why is it showing that it is law of conservation of mass? Because let's suppose we have 5 atoms, okay? 5 atoms in the reaction. So we get the same 5 atoms in the product also. Don't you think the mass of the reactants was because of these 5 atoms? Now the mass of the product also will be because of these 5 atoms, right? If one of the atom is destroyed, the total mass will not be the same on both the sides.
Yes, ma'am.
That's the same thing here. Come to the third point. Atoms of a given element are identical in mass and chemical properties. Atoms of a given element are identical in mass and chemical properties. In the second chapter, we saw that elements have same type of atoms. Right, same type of atoms. According to him, if the atoms are of same type, that is atoms of the element will have identical mass because they are same atoms, right? Will have identical mass, that is same mass and same properties. But it was not the case. Write it. Write it.
Okay.
According to Dalton's atomic theory, according to Dalton's atomic theory, atoms of same element have identical mass and properties. But later it was found that isotopes are present. Isotopes are atoms of same element with different mass. Example, carbon 12, carbon 13, carbon 14. Therefore, this was a drawback.
Done, ma'am.
When you're done writing, let me know.
Done, ma'am.
Done, बच्चे?
Yes, ma'am.
Now, what are isotopes? Isotopes are atoms of the same element which have different mass. Isotopes are atoms of the same element which have different
Different mass.
mass. Now, it was found out that isotopes are present for almost every element. Okay, like some elements have the isotopes. And what was Dalton saying? Dalton was saying that every atom of the same element will have same mass, right? And when we found out that isotopes are present, that point is wrong now. That point is wrong. Therefore, this point was a drawback because of the presence of the isotopes, okay? Because of the presence of isotopes. Have you understood isotopes?
Yes, ma'am. I think.
See, let's suppose if we have one element. So one element basically means all atoms will be same, right?
Yes, ma'am.
They are same, but what is happening? Let's suppose out of these atoms, Yes, Umar, fine. Is it okay now?
Yes, ma'am.
Okay. So let's suppose all other atoms are having mass of 12 units, but there are some atoms of the carbon element itself which are having a mass of 13 and 14 units. So what is it? They are atoms of the same element but with different masses. Therefore, these are called as the isotopes. I think that will be clear now. Fine. Come to the next point. What is the next point saying? See, atoms of different elements have different masses and chemical properties. Now, according to Dalton, if atoms of the same element are the same, atoms of different element will be different. Now, this is something that we have learned in the second chapter, that different elements will have different atoms. If you are one element and I am one element, my atoms will be different from your atoms, right? That is what we have learned in the second chapter. And that was the same things told by Dalton. But see, again, it was proved wrong. Again, it was proved wrong because of the presence of isobars. Because of the presence of isobars. See, Dalton's atomic theory said that atoms of different elements will have different mass. But it was proved wrong because of the presence of isobars. What are isobars? Atoms of different elements with same mass. Example, calcium and argon. These are different elements. Both have 40 units mass. Clear?
Yes,
As you saw in
ma'am.
the case of isotopes, isobars are atoms of different elements having same masses, and the example is this. Fine. So therefore, this again was a drawback. How many drawbacks have we learned till now?
Ma'am, two.
3. One was the divisibility of atom. We found out that it is further divisible into subatomic particles. Okay, second is the
Yes, ma'am.
isotopes, and the third is the isobar. Come to the fifth point. Atoms combine in the ratio of small whole numbers to form compounds. That is the same thing which was said by the law of constant proportion, that atoms combine in the ratio of small whole numbers to form the compounds hydrogen and oxygen. What is the small whole number? Two atoms of hydrogen combining with one atom of oxygen to form water. That's the same thing. Come to the sixth point. The relative number and kinds of atoms are constant in a given compound. The relative number and kinds of atoms are constant in a given compound. What are we saying basically? Let's suppose for carbon dioxide, number and type of atoms. What are the type of atoms here? Carbon and oxygen. What is the number of carbon atom? 1. What is the number of oxygen atom? 2. Okay. They are constant, they are fixed, they are definite for a given compound. That is the same thing. So therefore, basically these 2 points are telling you about the law of law of constant proportion. That's it. So all the postulates of Dalton's atomic theory are very important. The drawbacks of the Dalton's atomic theory are very important. And the third point is that what postulate of Dalton's atomic theory is based on what law? That is also very important. That's it. These 3 points are important from the Dalton's atomic theory. Is it understood, Umar? Please respond.
Yes, ma'am.
Okay. Now, what is an atom? Basically, till now, we have established that it is the atom which is participating in the chemical reaction. It is the atom which is combining together to form a compound or a substance or a molecule. Fine. So let's study about the atom now. We will specifically be studying about one atom now. Okay. One atom. It is spherical in shape. What is the shape? What is the shape?
Spherical.
Spherical shape. See here, just 1 second. We will write about the atom now. Okay, atom. Shape is spherical. Spherical, you understand? Right.
Yes,
Now, when
ma'am.
the shape is spherical, how do we measure the size? How do we measure the size? Okay, we measure the size by measuring the radius. By measuring the
Ma'am,
radius of the sphere. Yes.
ma'am, by finding its area.
No, by measuring the radius. If we are able to measure the radius, definitely we'll be able to know the area. Okay, fine. And basically it's spherical. Okay, so we will not be having the area, but rather the volume there. Okay, it's a three-dimensional this geometry. Spherical is three-dimensional. Okay, it's not
Yes,
two-dimensional.
ma'am.
Fine. So now we measure, what is the unit in which we measure the radius of the atom? The radius of the atom is measured in
Nanometer.
good. Nanometer. That is nm. We denote it using nm. And what is the value of 1 nanometer, bache? 10 raised to the power minus 9 meter. This is important. 1 nanometer is equal to 10 raised to the power minus 9 meter. That's it. Fine.
Yes, ma'am.
Fine. So shape we know, that is spherical. Size we know. We will measure the radius, and through that radius we can know the size. The size in the radius is measured in what unit? It is measured in nanometer unit. Fine. Now come to the names and the symbols. Name of the atom. Basically, what are we doing here is that we are having atoms of elements, right? So we will be referring to the names, symbols, and the masses of the elements, not the specific atom. Okay? Because why? Because atoms are a part of the element. Let's suppose we're talking about the oxygen element. So oxygen element will have oxygen atoms which are same, right? So instead of talking about each oxygen atom, we will refer to it as oxygen element. Fine. Now see, what are we having? Name of element with their symbols. So basically, instead of writing the full names of the elements, Dalton proposed that we write the symbols. Dalton first proposed about the symbols of the element. Symbols of the element, see. These are the symbols of the element, which were proposed by Dalton. Which were proposed by Dalton.
Delta.
And why were they actually not considered? Because see, what is the point here? Dalton said that these are the symbols. Now, if you see very carefully, they are not very accurate or they are not very convenient to use. Example, let's say that in making goal, instead of making 8 points there, I make 9. So that is very inconvenient. Okay. And they were also not very standard, as in you might be using some other, I might be using some other symbol. Therefore, we needed some standard symbols which are also convenient to use. Then we had J.J. Berzelius. J.J. Berzelius suggested that the symbols of elements be made from the letters. Okay. So what did J.J. Berzelius say? J.J. Berzelius said that instead of assigning some other symbols, what we do is that whatever is the name of the element, we write that name and we take the first or the second letter for the symbol. Okay. We take the first or the second letter as the symbol from the name of the element. Let's suppose you are Omar. So how we will take your symbol? We will say, since your first letter is U, we will take your symbol as U. Is that understood?
Yes, ma'am.
Fine. Now see, we have elements in different languages. We have the name of elements in different languages. Okay, and
Languages.
that is very important. English, Latin, Greek, whatever languages we are having, we will write the name in that language and we will take the first symbol from that language. Okay, so see, some of the elements are named based on where they were found. Some of the elements are named in Greek, Latin language. Some of the elements are named based on their color. Okay, so these are the different categories on which elements have been named. Okay, see here. For example, the name copper was taken from Cyprus. Why? Because it was found there, okay, where they were found for the first time. So copper has a symbol as Cu. Second, some names were taken from the specific colors. Very important. Example, gold was taken from the English word meaning yellow. See, gold basically is this. Now it means yellow in color. That's it. So why has been gold named as aurum? Because its color is yellow. Are you getting it?
No, ma'am.
No. What is the confusion here? Please say. Please ask Vachi without any
Ma'am,
problem. Huh.
ma'am, I don't know how to explain that question. Can you explain again?
Sorry? Yes, I can explain again. See, we will explain it here again. No worries. Basically, what are we trying to understand is how did this elements Yes, I think my network is having a lot of problem. Fine. Come here. The name of the element could be taken due to several factors. The Yes, Omar, I think we should stop the class now. It's having problem, okay? So we'll continue it in the next class, okay? Thank you.
Okay, ma'am. Thank you, ma'am.
But revise.
Okay, ma'am.